To all, I Ravi Kumar Paliwal, Assistant Professor, Electrical Engineering Department, Parul Institute of Technology, Parul University, welcomes you all all for this webinar on communication and information technology of smart grid. Now, I would like to introduce our expert, Devashish Kumar Patel. Sir has completed his master degree in Power and Energy System from NIT Silchar, Assam in 2014. He has worked as a assistant professor at Parul University from 2014 to 2018. Sir is working uh, currently. He is doing PhD in Power and Engineering System at NIT Silchar, Assam. He has published many research papers, national and international. So now I would like to welcome you, sir. Now I hand over to Devashish, sir.
Thank you, Ravi sir, for your kind words. So, very good morning to one and all. So, as Ravi sir, as you told that today we are going to discuss about the communication and information technology of smart grid, right? So, before going for communications and information technology, I am audible, sir?
Yes, sir. You are properly audible.
Okay, sir. Thank you, sir. So before going for communication and information technology of smart grid, first we will discuss what is smart grid. Then we will go for the communications part of a smart grid and its importance and in role of communication technology in smart grid. Then we go for the information technology, what is its role in smart grid, and at last we will see the future scopes and the research possibilities in smart grid in the area of communications and information technology. Okay, coming to the contents. In content, first as we discuss, we first going to cover the what is our existing electrical grid and what are its drawbacks, so that we go for the smart grid. We first discuss about the existing electrical grid, then after we will see the what are the affecting factors affecting our existing grid, means what is the main factors that are affecting our existing grid, so it motivates to switch our to smart grid. Then we will come to the smart grid definitions, then we will detail discuss about the smart grid components, and in smart grid components we will only focuses on about in detail what is the smart grid communications and what is smart grid communications technology and its future scopes. Okay, coming to the next slide is our introductions of electrical grid. I think you, as you all know that electrical grid is nothing but what it transfer electricity from our generations to our customers, right? So the power is transferred through transmissions line and distributions line, and many equipments are also there. So this is, if you will see our definition, electrical is a network of synchronized power providers. Obviously, what is the word of synchronizing power? As you all know that synchronization should be maintained whenever we are transfer the power from our generating to our customers load end, okay, or consumers are, and through connected by transmission distributions line, and many operators are also there. But in existing electrical grid, what will happen, there are so many controllers are there in existing grid, so many controllers are there and they are manually operated grid. Okay, so in this existing grid, so many having we have problem. That's our problems are what, increasing demand electricity. As you all know that nowadays as the populations are increasing day by day, so what the demand of electricity is increased. Due to increase of the demand of electricity, our grid become more complex, right? So in the complexity of the grid, to maintain the complexity of the grid, it is having, we require some more advanced version of our electrical grid. As you all know that electrical grids are also there in our India. There are so many national grids are there. They are still operated in manual conditions, but we are trying to convert all this in near 5 years. We will try to convert them to into smart grid. Then again, if you will next, shortfalls is nothing but your supply of electricity in the complex network also, huge amount of consumers are there. So what will happen, we have deficiency of electricity. So how to compensate the deficiency of electricity in our electrical grid, that also compensate by our smart grid. We will see how we can overcome all this. Then need of reducing losses. As you all know that as the network is become more complex, transmission lines are more. So when happen, it will increase our reducing losses, because whenever you are transfer the power from your generating station to your consumer end, what will happen? There is long distance to you have to travel. So whenever power will travel for long distance, so there is lot of losses will be take places, more voltage drop will be take places. So all this problem will come into arises in our existing grid. And apart from that, what will happen? Peak management. What will happen in nowadays? Our consumers are not aware about the pricing of electricity. So as you all know that if you will run your house appliances like fans, heaters, micro oven at our peak hours. Peak hour is something like in between from 2 to evening. At the more evening hours, what will happen? There is a peak, because in that peak evening hours, our industry are running, our all households are running because they are returning back from offices. So at this interval at the evening time, what will happen? There is a very huge amount of demand of electricity. Or in other way, you can say that in any festival season or any festival day, what will happen? The demand, peak demand of electricity is higher. So how we are going to manage the peak demand so that we can decrease the electricity tariff, right? This we can, as you all know that in many state the price of electricity is increasing, per unit price of electricity is increasing. So we have to decrease the per unit price so that our customer can get more benefited, are getting beneficial from our electrical engineers or our systems. Again, integration of renewable energy is must. As you all know that I think few days before you listen or you heard that the coals reservations at many thermal power plants are decaying. So what will happen? The integrations of renewable energy is must for us. That's why we are planning up to 2050, 2025. So many solar energy must be means in huge rate. I'm not going for specific what amount of megawatt or kilowatt is going to be installed, but most of the time we are covering 30 to 40% of electric generations from our renewable energy. Then coming to your solution of global warming, what is global warming is day by day increasing because our carbon monoxide footprints are increasing in our environment, because our thermal power plants are continuously running and your emissions of your carbon monoxides, and they are not able to check their quality of production of electricity also. So these are the problems in our existing electrical grid. Now again, if we are going in our in this era, what is advancement we are coming with? We are to compensate our carbon monoxide from elimination from your bikes or all these things. Also we are switching to our deficiency of electricity, petrol prices are increasing, so we are that going for what? Electric vehicles. So whenever we are coming to electric vehicle, it also increase more complexity to our existing grid. How we are going to incorporate our electric vehicle, how we are incorporate the charging stations in our electric grid, how we are going to manage all this, because we cannot stand like petrol pump, right? You always we have to, because there is huge electric vehicles are increasing as for our consumers. So we have to go for special arrangement for them, or special charging stations should be there so that they will come and they can charge your electric vehicle, right? Better customer satisfaction. Lastly, what whenever we make better customer satisfaction is also more challenging in our uh, present electrical grid. We have customers are not getting better satisfaction because in terms of price, in terms of flexibility, or more are challenging. And potential advancement are also happening day by day. What will happen? We are going for technological advancements, like we are using more sensitive devices, more non-linear power electronics devices are there. So they require what? More sustainable quality of power are required. They are not interrupted power are required. So for these all these reason, our existing grid required modification, upgradation, and so that if you go for the upgradation, so that our customers can get more satisfied, right? So these are factors which motivate us to go for smart grid. Now comes the smart grid. What is smart grid actually? This is digital technology that allows for two-way communications. First, what will happen in existing grid? There is a one-way communication. That one is something like electricity passes from your control system, control center to your consumer sent to our villages, right? This is one way communication only, but consumers are not going to give their feedbacks, right? So what will happen in smart grid? We are providing two-way communication, so in such a way that consumers can also give the informations, right? We can collect information from our consumers and also, right? Now we will see in customer perspective how smart grid is provided. So in one word, if you define the smart grid, it is a digital technology which provides two-way communications between utility and customers, and sensing along the transmission line is what makes the grid smart. Also means there is a transmission or communications between consumers and our utility is nothing but your control center. Apart from that, in the transmission line we have so many sensors devices are there, so that we can sense their present status or present conditions, right? Coming to the customer perspective, smart grid is similar as the managing activities, like your personal banking, right? In personal banking, what you are doing generally, whenever you are depositing your money, right? Then you have a transaction, daily transaction, per interval, whatever you have transactions you did by your ATM card, whatever you mean, all the transactions you have, and you come to know that what you have balance, right? So here also similar smart grid is similar to managing activity such as personal banking from home computer. So what you are going to manage your electricity consumption by sitting on your home. You can see that what amount of unit you have used in per day, what is the price for this hour. Nowadays in villages or in our board, what they are keeping fixed price, but in coming days what we are going for switching for, we are switching for variable price. As for your consumptions, the price will be decided, right? So if you are going for peak hours, in peak hours if you are running your more appliances, means more devices or home appliances, then what will happen? You have to pay more if you run your devices in peak hours. So what will happen? Smart will provides that in peak hours it will show what is the unit price of your electricity. So you are aware about, no, I am not going to turn on my more devices in this period. Let switch this work to other time. So you can manage your price also. So from home also your smart grid will provide how to manage your electricity consumption, right? Apart from that, customer will no longer have to wait monthly statement. As your monthly statement is come for every month, then you have to don't wait for that one. You will get that how much electricity he or she used. You will get as much as you when you want. With the smart grid, he can have a clear and timely picture of throughout the smart meters. Means you have clear pictures of your consumption through your smart meters, because in smart grid smart meters are mostly used. So smart meter gives your every informations, like what amount of energy you are consuming, what is the unit price at this moment, what is your power factor of your loads. All these informations will be displayed on smart meters. right? We will see what is smart meters in our incoming slides. Customer can also able to see how much electricity he's used when he use it, right? You can able to know how much you use per day, per hour, all these things. Customer can save money whenever you have see the things on your eye, you can manage, right? So whenever you are spending of money, you can see from your bank account, obviously you come to know how to manage your money. Like that you are going to manage your electricity here also through smart grid. So coming to the next slide, this is the most important part of smart grid model, right? So what is the component that makes our grid smarter? We will see here. So first one is what? Generations part, transmissions part, distributions part, and our home appliances, right? So from here in generations, what we have? Bulk generations, PV, wind, storage. Then this one is your transmission part. Then after going for transmission is what? Having our voltage level is higher. So we go for step up transformer. As you all know, I think in your power system classes, right? Then this one is your step down transformer. Step down transformer will reduce our voltage level and brings back to the our home appliances use, means in specified range. The voltage should be specified range so that our appliances are you are get suitably used, right? So this is our physical layer through which our power is transferred. That's why this is called physical layer infrastructure of our smart grid. Apart from that, what will happen to bring the smart devices are going to use. So this is something smart device like sensors are throughout your physical layer, they are present. Camera are there, smart energy meters are there, RFID are there, fault current indicator are also there, remote terminal unit, load control switches are there. Means all these devices will sense the present condition and present status of your electrical grid. Maybe sensor sense any abnormality, any fault will occur. Then also sense by your fault current indicator. Then RFID also like what your chip. I think you come to know what is RFID. Then I will discuss that one. Smart energy meters, as we discussed, smart energy meters also, it will gives continuously what amount of energy or what amount of power, what is your power factor you are using, right? All informations you will get from smart energy meters. Apart from that, RFID. So whenever your RFID is something like in grid, generally what will happen as we comes under electrical vehicle. Whenever we comes under electrical vehicle, what will happen? You will go to your charging station, right? In charging station, you no need to register yourself. Like your driving license, whenever in nowadays, what will happen? In driving license, there is chips are there. In ATM card, there is chips are there, right? The chips is nothing but RFID. This is that RFID chip having your information. This is something like your name, your address. Apart from that, what it will give the what is the condition of your bank statement, what is the your balance, right? So similarly, whenever comes in the electrical vehicle, this RFID register your electric vehicle number, what is your charging power condition, all the informations are stored there. So once you enter the charging station, what will happen? All the information will be sent from your RFID and you process your informations and you will charge what amount of charge and it will be deducted from your account. What amount of you're charging the electricity, that will be amount of power is deducted. That RFID is also nowadays you are using in something like tool tax. Toll tax is something like now we are going automatic, right? So there also we are using RFID. So what will happen whenever your bike or vehicle will be passed? What will happen? They'll automatically deduct from your bank account. So here the same provisions we are going to be apply for your electrical vehicle, right? So there is so many devices that makes our working processes more smarter. So once you are sense all this information through your sensors devices, what will happen? Next step is our to process the information or transfer the information to somewhere, exchange the information. That can be happened through Internet of Things. Nowadays, in research emerging smart grid technology, we are using one topic that is called Internet of Things. Internet of Things, what it will uh, this is something like network which will communicate helps to communicate between two sensors or it will helps to communicate between sensor to the our of information technology or control center through your communications devices, through communications layer. So similarly, obviously, whenever we sense the devices and some of the data, we have to transfer somewhere. So how we can transfer? Through our communications devices. That is called communications infrastructure. So in communication infrastructure, as you all know that how we can faster we can communicate through via our wireless and wire communications. So in communications is also again divided into two parts. First one is wireless and second part is wire communications. So Wi-Fi, Bluetooth, WiMAX, power line communication, PLC. No, it is not PLC, something like you use. Here we call this power line communications. Zigbee also is some communications devices that are wireless communications. Satellite, as you all know, now your satellite displays are also there, satellite TVs are also coming. Fiber optic communications are also more faster transformations of information. So when all these transformations are communicate, that should be stored, managed, and processed and analyzed. That is called information technology. Okay, so in information technology, what it will store all the information and it will process and it will be analyzed and it will bring out what is the conclusion from that. Means if any disturbance, like in smart meter you have the sense your phase difference is much more, phase difference is much more. So what will happen? Your power factor is very less. So what power factor will be says means that decisions, that information will be calculated, manipulated, analyzed by this Internet of Things, cloud computing, and big data. As you know that big data is what is responsible for manage your massive data. Now in electrical grid, what it will going to collect more massive data. So to store the data and process the data, we require what? This technology. Sorry, that is big data, cloud computing, Internet of Things. So once you analyze this data, this data will transfer to what? System engineer. That system engineer will decide what the actions will be take places, or so many algorithms are automatic algorithm are also there in our cloud computing or big data. So automatically also they can take the decisions also, right? But still, if you do also transfer the information of system engineers, those are in their control systems, they are also monitoring. But if more abnormalities conditions are will happen, it will go to our system engineer. Otherwise it will store or it will give the corrected algorithm from this information technology. Again this information will be shared with others, Genco and Transco. As you all know that in our state electricity board is again it transport to many grid, right? As you all know that our Indian grid is divided into five regions: northern region, south regions, east regions, west regions, and eastern region, right? So like this, each regions again it is divided into many states, and again many states are also divided into what? Genco and Transco. So these are already all are interconnected. Like we are going to like this, we have to make the smart grid. So smart grid, coming to your revision, this is a four layer communications, four layer, it is a four layer, and the communications will take places between these four layers to provide sustainable power, to protect more security, and provide some automatic operations. Okay, this is completed your smart grid model. Now if system engineer, if chance, it will give you power system the instructions, what is the changes will be happened in our power generations, what amount of power should be transferred. That can be also given through to the your generating station, right? Now coming to the next, the standard definition of smart grid. We know now what is the discussion of the overall the smart grid. Now what the definitions are given by our different boards, right? The European technology platform of smart grid, it defines that, I'm not going to details about it. Means they have smart grid and electricity network that can intelligently integrate the actions of all users connected to it, generators, consumers, and those that do both in order to effectively deliver sustainable economic and secure electric supply. Means something you have to develop that grid that having some innovative products and service also, and at the same time it also able to transfer the sustainable economic and secure electric supply with intelligent monitoring, control, communication, and self-healing technology, right? So he also defined that you have to transfer the electricity in such a manner that it will be sustainable, economical, and electric supply with providing of your intelligent monitoring, control, communication, and self-healing, right? So coming to the US Department of Energy also defined the grid 2030 envisions means we are looking for fully automated. We are looking for a fully automated power delivery network that monitors, controls every customers and node, and ensuring we are providing two-way flow of information, right? Two-way flow of information, as we discussed in the starting of the class, that two-way information of flow is what? Something like electricity is passing from your generating to your load end. Similarly, the consumer also send the information to our generating station, right? This is a two-way communication. And coming to the International Electrotechnical Commission (IEC), the smart grid device is developing network of transmission line, equipment, control, and new technology working together to respond immediately to our 21st century demand for electricity. So in 21st century, we are going for the more fastest response. So coming to the next is what is difference we see, right? Now you can, this is electromechanical, means whatever you have to do in existing grid, you have to make mechanically, you have to switch the load manually, right? But you had, whenever you comes to the smart grid, it is digital. This is one way communications because only electricity is passes from your source to load end. But here the two-way communications will be possible. That is from your source to load end as well as from load to, sorry, consumers can send what is the amount, means the smart meter sends the information, that information is given to your control systems or our source end. That way we go for a two-way communications. Centralized generation. Centralized generations means what? Here we have existing grid. We have many. We have depends upon thermal power plant or hydro power plant. That is called centralized generation. But here we have distributed generations. Means something we are going to incorporate the renewable energy, right? Renewable energy, wind energy, so that whenever you incorporate this renewable energy, what will happen? This also provide our carbon emissions reductions. Deficiency of electric supply also can be managed through our smart grid, right? Obviously, and more next point is what? Limited sensors. In existing grid, we have limited amount of sensors. We generally see the relays part, right? But here sensors are throughout. Sensors are throughout, like transmissions line, distributions line. In generations also sensors are there, and continuously they are monitoring what is the happening in our grid, what is the power, what is the temperature is within the acceptable range or not. All these things they are monitor sensor through sensor. Manual monitoring, here what we are doing, manually you are correcting the frequency, but here we have manually correcting the voltage and frequency. Failures and blackouts will happen in central or existing break. What, as you heard that name also, blackouts are happening, right? But in smart grid, we can't go for the blackouts. We go for isolating, adaptive and isolating. Here in existing grid, what you have limited control. Here it is fully controlled. Here manual restoration. Here you have self healing. Here fewer customer choice. Here many customer choices are there. So self-healing is also what? Anything will be happened in our smart grid that will automatically get corrected. But here we have to restore, we have to take time, restore the network. If it is any faulty party is there in our network, then we have to cut that one supply and we have to wait for something. But by using the sensors, using the automatic devices, automatic switches, we can, in running condition only, we can change our network condition and we can isolate our faulty part of your network. So these are the facility provided by our smart grid, so that things are done easily, timely, and provide power supply more sustainably. So coming to the next slide is our smart grid infrastructure. What we discuss here also, we are not going to discuss more in detail. Physical layer, device and sensor, communication infrastructures, and information technology. Communication infrastructure is something like your Wi-Fi, Bluetooth, Zigbee, Z-Wave, something like all information technology are there. The four layer we already discussed. We are not going to detail now. Now coming to the what? Smart grid infrastructure, again it is divided into two, at that is four layer. Now it is divided two part. Smart energy meters like power generation, transmission and distribution, so we discussed this one also. Smart information also, what? Smart metering, sensor, phasor measurement unit, information management. So we will see what is the smart information systems and what are the equipments, we will see in details. So we discuss this one. No, discuss that physical layer and upper part. They here also in smart energy systems having the physical layer, and smart information and communication is other three layers. So coming to next is nothing but coming next the smart energy system. There is power generations. How power generations will occur, and it provides true flow of electricity, expected demand. Demand can drive the generations, and the supply demand equations, how we can balance, right? Transmissions, as you all know that in transmission, what new material, advanced power electronics, communication technology drives the development of smart transmission grid. In transmission lines we have so many power electronics devices are incorporated to convert rectifiers operations, inverter operations, right? HVDC are also uses na. So here in transmission line are also you are using power electronics devices, and those are smart devices. We can give the signals, we are give the firing angle controls, all this we can automatically, we can do all this, right? I think you know power in power electronics, all this in rectify inverters. So coming to the next one is distributions. As you know, the distributions is distributed generations level are increasing nowadays. To as distributed generation at distribution level increase significantly, therefore power flow control much more complicated in distribution level. To overcome above problems, smart microgrids are formed at different voltage level and distribution systems. So these are the physical parts where we have required the smart grid. Smart information technology. Now the smart information technologies are upper three layer. So smart grid technology consists of advanced power electronics device but having smart information system. Smart information system consists of what? Smart components, smart communication and information technology. So whatever information they are collected from the physical layer, they have to what? They have to model the information, integrate and analysis and optimize the information so that they can take proper decision. Okay. So now we will see that each component, that smart meter, sensors, PMU or fault current indicator also, camera, RFID, remote terminal unit, load control switch. So these are the few components I have taken. This you will see in detail, and these are the most important component. So coming to the first one is smart metering. Smart meter usually an electrical meter itself that record consumption of energy in interval of 5 minutes, 15 minutes, half an hour and hour and level interval. Means what? This is the meter that can sense the informations for the interval of what? 5 minutes, 15 minutes, half an hour and 1 hour level. So what level in each instant also you can sense the condition and status of your electric consumptions. So coming to the next is what? Automatic meter reading, very commonly known as AMR. First, initially we are using automatic meter reading system. Okay. This technology helps to collecting data from energy meters, transferring the data to the central database for billing, trouble setting and analyzing. Automatic infrastructure, that is so-called AMI, differs from traditional AMR. In it enables what? Two-way communication with meters. Means what? Your utility also give information to your smart meters, and the smart meters whatever it consumes from your store information, that will automatically transfer to your consumers, which is not possible in case of our AMR. So that's why the automatic infrastructure is called AMI, that provides smart metering features, right? Two-way communication with meters, right? In real time. In real time you can exchange the information so that you can take proper decision. So coming to the next one is sensor. Smart grid use sensor to provide what? Quality of service, resource constraint, remote maintenance and configurations, high security requirements, harsh environmental conditions. So in sensor, what will happen if you have any let one sensors which sense your it sensor, it sense heat, right? Or you can, it can sense also your any spark will happen, so it also So what will happen whenever you are going for maintenance or configuration, reconfiguration, remote reconfiguration, this sensor will be helpful. So whenever you come to that, you come something is burned in your electrical transmissions line. So what will happen? We have to transfer that load with other feeder. Means, let one example that one feeder is light burn. So what will happen? Some loads are connected to our feeder. So what we have to do? We have to reconfigure the network to transfer that load to some other feeders. So this is like some reconfiguration that can be also happened automatically with the help of sensors and automatic PMU devices. That also like sensor helps. Now the most important part is PMU, phasor measurement unit, right? This what will happen as it is integrated with our now smart meters. So what will happen, as you already discussed, that it also detects your power factor. It will detect the angle between voltage and current. Means it is per second it will store your informations. Means per second how the voltage waveforms is going, what is current waveform is going. So from that it will calculate power, it will calculate your phase angle, everything it will be calculated from PMUs. And also if you detect the continuous waveform of voltage and current, then what you have to do? Provide loss of main protection, monitoring of fault event. You can sense the fault event, locating disturbance, estimating grid states, right? Studying synchronous isolating operations, monitoring power quality. All these things are also can be possible through PMUs, as you sense the phase angles and magnitude of voltage and current, right? Now coming to the next is RFID. RFID, as you all know, that in your ATM card also chips are there, in your driving license, all this. So scheduling of control of loads means schedule of control of loads also helpful. Means scheduling of control of loads means in which interval what amount of load should be there. That scheduling can be possible through your RFID. RFID will be sense the amount of loads it is having, and it is having higher huge amount of load for that interval. What we will do? We will change that load, right? Similarly, automatic identification of smart appliance status. Okay, status you can monitor through RFID, as we already discussed this RFID, right? Power control of electrical outlet. So it is electrical vehicle or electrical outlet is something like if you are going to something like you are selling your electricity, right? In IEX, Indian Electrical Exchange, what will happen? You are trading the electricity. Means some industry are buying electricity from our central outlet. So in that also your RFIDs are used. Means per consumers are also identified by your RFID chips. So similarly, payment, ticketing through the power lines also, electric vehicles are also possible through your RFID. Payments and all the ticketing procedures are helpful through your RFID. RTU. Next one is your RTU is the most important part. Protection schemes. RTU is what? In the straight grid, we have different remote terminal units which are nearer to our grid. That having some special algorithm. Means if you have any fault will occur, they will provide some protection schemes, fault isolation schemes, means network reconfiguration and protecting resetting. All these remote terminal units are also going to decide how to control the faults, how to control the reconfigurations. Reconfiguration is what? Exchanging of feeders in your distributions line, right? So these are possible. Now coming to the smart information systems, we discussed initially what? Smart components, which are near to our physical layer. And after collecting all this data, we go for smart information system. So in smart information system, what is there? IoT, big data and cloud computing. Mostly IoT is what? Transferring of data. IoT is something like transferring of data, Internet of Things, used to obtain information gathering, processing, computing, networking, and exchange of data utilizing smart grid. Obviously, it's gathering, it will gather your information, process the information, and compute. And networking is what? It will send the computed data to the all devices. It will help to your Internet of Things. Also, IoT is a network to connect any smart device to other, to trade information and to monitor, manage, recognize the location and every object in the smart grid, right? So what will happen? IoT also works like a network that will transfer the information from one smart devices to other devices, or for trading purpose also we are using IoT. But to help IoT, what will happen? We have the provisions to store the more data, right? And we have to store the more data in such a way that that will be so more secure also, right? That is called big data, cloud computing. So what big data? Information management, analysis of massive data generated by our diverse power devices, smart devices. Cloud computing also similar to our big data, but massive data management will also take places to your cloud computing and big data. So as you will see, these are the smart informations is where in our model. In the upper layer, these are the Internet of Things, cloud computing, big data. This will process our information. So now coming information technology, where we are this one we have overall up to this we cover every part in details of smart grid. Means you can say that smart grid is completed. The basic part we covered in the smart grid. Basic part, what is the most important part, is we have already covered. Now we will go faster little bit to cover the future scopes. In last 10 minutes we will cover the what is the future scope and what is the recent advancement. Means we use already IoT, but still it is having some drawbacks. Still it is having some. We require some more future scope. We will see. So before going for future scope, we will see the detail of communication. Right? As your topic is what, communication and information technology, we will go in detail of communication technology now. So coming here, communications. So this is here what I am giving here. I think my pointer, the mouse pointer is something looking here. What is gives, this is the small modeling of our smart grid, that is from block generation, transmission, distribution, and customer end. So this is the one way, and all other devices are interconnected, right? So this will give you the smart operations, and also giving us the smart operation. Also, it will facilitate your smart operations in smart grid for your communications only. The smart facilitation will be given by your smart communication. If you have no communication, the smart operations will be not possible. That's why communication is most important in our smart grid. So what will happen? Whatever the communications will be take places between our consumer and customers, and that is comes under home area network, building area network, IN, this is called HAN, BN, IN. What is this called? This is the communication will take places on our home area, right? Similarly, NAN and FAN. NAN is a neighbor area network. Neighbor area network is something like in present in distribution system, like to communicate between the different distributions, between our renewable energies. So these communications, which will going to provide this communication, that is called NAN and FAN. FAN is also your uh, field area network, right? Field area network, neighboring area network, industrial network, building area network. So many they are in distribution area. Now, when we go for transmissions and generations, the information transformation will take place through our WAN. WAN stands for what? Wide area network. Means something here we have to travel the information for longer distance. Similarly, NAN and FAN, narrow area network or FAN, you are travel the information for about 10 kilometers. But whenever you are HAN, home area network, building area network, there will transfer the information about 100-meter areas. Okay. So these are the widely means randomly we describe this one. Then again, these communications will be divided into wireline, means wireless, and wireline means some are we are transfer the information through wireline, and some information will transfer through wireless. Okay. So in wireless communications, we have different types of communications we are using, and each communications are having some spectrum. Use bandwidth, the transfer of information, data rate. Means as you know in mobiles you have some, whenever you are using the data rate, right? Coverage range, we are also using what? Coverage range, applications, and limitations. Every communication also we have limitations, right? Coming to the next, we will see the details of communications. So in communications also, as we see that HAN, then we have what? uh, Distributions, this non neighbor area network, then long range wide area network. So in short range we are having some data rate that is from 100 kbps we are using for smart short range communications technology. Then it is coverage area about 100 meters. right? And technology which are responsible for short ranges are what? Zigbee, Wi-Fi, Z-Wave, that power line communication, Bluetooth, Ethernet, customers, and the level of power communications is customers, and power consumptions for this communications technology is low. So coming to the medium range, whatever medium range means we have transferred through your distribution system, generally in distribution system, that so this is data rate is having 100 kbps to 10 mbps up to 10 kilometers. Similarly, cellular communication technology or 5G, 6G are you are using comes under your medium range. This is come distribution system, that is medium range power consumptions. Again, long range is wide area network, that is information transfer take place between what? Your generations and transmission. So for that one, what the data rate that is per 100 Mbps to 1 Gbps. Obviously, whenever we are dealing with long distance, our data rate should be more, and coverage area is also 100 kilometers. This is called optical fiber, cellular, WiMAX, satellite. We are using this communication technology for longer distance of communications, like generating system, transmission system, and power consumption is high for this one. So now this is the some random classification: short range, medium range, long range. In short range, we go cover small distance. Medium range we cover then like up to 10 kilometers, and long range is about 100 kilometers, right? So now if you see the characteristics, every communications technology having some characteristics, right? Means what? Like if you consider 6G, it is also have take time, or whenever you are using Wi-Fi also it takes some time from sending end to receiving end. The data will be transferred within at some time. That is called latency. So now we will read one by one. The each communication technology take time to transfer data from one source to destination session or vice versa. Means whenever your Wi-Fi will take some time to transfer the data from source to load end and load to source end also, that is called latency, the time required. So obviously this time required should be less. Means whenever you are using or whenever you are going for preparing some communication technology, this latency should be less. Bandwidth, obviously whenever you are going for transfer the communication of data rate, it is having some bandwidth should not be means in suitable range. If you are higher bandwidth, lower bandwidth, if you lower bandwidth, it will lower bandwidth means what? You have cut up frequency. So if you are eliminating some noise, or also we are avoiding some other part. So whenever you are using your Dix TV, also every channel also having some specific bandwidth or frequency, right? So here also we have specific bandwidth as for our convenience. It should be coverage area. Obviously a communication technology having some coverage area, how much distance it will cover, and in how much within how much distance it will communicate, right? Coming to the data rate, in which data rate it will transfer the data. Coming to the reliable, also the communication technology should be reliable, and security must be there in our communication technology. Clear? Now next one is your that communications technology. In communication technology, this is in detail in this wireless and wired. So cellular network, Bluetooth, Zigbee, low power using Z-Wave, Wi-Fi, cognitive radio, microwave communication, WiMAX, satellite communications. All these are your wireless, and wire communication of fiber optics. That is your power line communications, DSL. So these are having some technology which are using having the data rates, coverage area, spectrum, that is my bandwidth, and applications, right? So now we are using what? Up to GPRS, LTE, 2G, 3G, 4G, 5G, up to we have seen. So now our next advancement is our 6G. So whenever you are going for your smart grid research, you can use 6G in IoT. IoT integrate with your 6G. So it will provide better flexibility, better advantage than previous one, right? So similarly, the advancement will be take places. So now next one is what? Next, whenever you coming to this communications technology, our different institute board having specified different standard. Like first one is your standard, like your in Institute of Electrical and Electronics, IEEE, also define some standard for our communications technology. Similarly, coming to the next one is IEC, that is called International Electrotechnical Engineering. International Electrotechnical Engineering also defines some board, means some standard through which for information and technology or communication should be work. Like CBER, American National Communications, American National Standards Institute, ANSI. ANSI also defines some guidelines to operate our smart grid, right? International Telecommunication Union, International Telecommunication Union also defined some standard for all our communication and information technology. I'm not going to details of this. We can see this one. So now coming to the next one is smart management system. Now we will covering all this first part, communication part. So whenever we are going for communication information technology, where your process or where you are going to decision, for that one, the main important work of your smart grid is what? One example I'm giving, that is smart management system. Smart management system, how we can manage the system? See here, in smart management system, the example is demand side management. Demand side management means what will happen? Continuously our load demand is increasing, decreasing, so we have to manage our load. What will happen? Whenever we will see load shifting, load shifting is what? Whenever we have peak load, so we have to distribute this peak load to our less, when in our day when we are using less amount of load, there we are going to shift our load. So this is called load shifting. Valley filling means what? We can also do whenever we are using less, we can increase our load. Peak clipping means we are reduce the peak load. So all this can be happen through your smart grid by sensing our what? Demand response. So what will happen? Demand response. What is demand response? Whenever you are consuming the power, we are plotting the curve per day, means per each time what amount of load you are consuming. That if you plot, these plots comings are like this. So by seeing the plot, you will do this demand side management, right? That can be possible through your smart grid. So whenever you are doing this process, we have getting so many obstacles. So what are their obstacles? So we will see in smart grid. Smart protection. Obstacle is from in generations, distribution, and consumptions. That is cyber attack. Cyber attack 2, cyber attack 3rd. So what will happen? As you operate in communications and internet, what will happen? There is a chances that some will attack our generation. Means some generations will be get, if you transfer information through our internet, that this generation should be up. That can be happened by our threats also. As you all know that nowadays cyber attacks are more are happening. So what will happen nowadays? Whenever we are going for the communications and the information technology, it should be designed in such a way that it is more safe from our any attacks. So the cyber attack can be attacked our distribution control also. They can uh, switch off some distributions line or distribution station also. Then cyber attack can be take places in consumption side also. In smart meter, if internet through you, if you will send the signal that the unit price of your electricity is less, so when it will show less, what will happen? Consumers feel it is okay, it is consuming less power, you can use more power in this condition, but it will show you more cost. So this type of operations or protections are required in our smart grid. And these cyber attacks are can be happened in our IoT or in our information technology. To provide these protections, we are going for higher research in our communications. Higher technology we will prefer to our save our protection. Clear? Or provide better protection. So now, load altering attack, that whatever we discuss, they will send the attack from your data centers and it will be damaged. Similarly, when it will give signal to your smart meters and it will be whatever the readings, that can be alter change, right? So coming to the next is your false data injection also, as we discussed that a residential load is increasing, but price of electricity is decreasing. So what will happen? This is false data injections through your smart grid. So this can be happened. So we have to protect this attacks So we have to bring the protection system, that is protecting commands in our price signals, protecting smart meters and data centers, attack detection, learning demand patterns, load setting and relocating. All these things we have to see. Okay, means you have to depend. So the what is the actions we should take in our communication information technology, that is in terms of our future scope. We are going for software defining network, 6G cellular mobile network, cognitive radio, big data, cloud computing, edge and fog, blockchain. These are provide more security and more faster operation to our smart grid. So nowadays researchers are doing research on this field. So if you are now, you know the smart grid, how it will operates, now you can go for it. There is some research on this field. Okay. And some technical, you can demand side management with our edge and fog blockchain, like you can do the research. So in software defining network means I'm not going to detail in detail. Network and its reconfiguration, network efficiency, it will give network efficiency, flexibility, dynamic resource allocation, traffic rotating communication network, management, security, resilience issue also resolved by software defining network. Okay, so coming to the 6G mobile network part, now it is the fastest and advanced version in our cellular network, which is having ultra dense site, ultra reliability, interoperability. Next generation's communications technology 6G expected to overcome all the shortcomings of 5G. Means you can go for more generations of communication technology so that it can be suitable for our smart grid. Again, 6G communications technology assets, IoT, SDN, cyber attacks, effective grid management, overcoming IoT limitations, all this, right? Now, cognitive radio also provide what protect frequency resources by accessing unlicensed radio spectrum. What means whatever your assessing information will come means it having some frequency and it is having some license. So whenever cognitive radio is there means for whatever your information or whatever frequency will come, it is having some license version. So what will happen whenever your frequency will come with some license, then it will provide more better protection. So you can go for in cognitive radio in details to advancement of your research. Big data, as you know that how to store more big data, how to incorporate IoT with big data, how to incorporate cloud computing and big data. All these things are going to your future scope. Cloud computing is what? Cloud computing, as we discussed, right? In storing of data and processing virtually, which is facilitate our decentralized energy management. Means we are not going for centralized management. We can isolate in area and we can take decision, right? Edge and fog. Edge and fog also provides your decentralized control and facility. Blockchain also, it also provide more secure transmissions immutability. More means information transmission is more secure in blockchain. So like this is the future scopes. Thank you for your attentions for apart from this 1 hour.
Okay, thank you very much, Devasi sir. And I want to arise
Thank
one
you, sir.
question over here, sir.
Yes, sir.
Uh, my question is that what are the challenges to apply the smart grid model to the existing system?
Oh, means what are the challenges we have in smart grid? Sir,
Yeah,
in
yeah.
generally
This,
nowadays what will happen, there are so many cyber attacks are going to be happened, and
yeah,
we are whatever the information will be transferred with our generating station or our consumers, that should be secure. And what will happen sometimes, whatever the information will transfer, that is having some noise. So for this to eliminate these challenges, we going for this cognitive radios, cognitive radio, cloud computing or cloud computing. So what will happen? We discussed that at the time. So whenever we are transferring some frequency, we are abstracting some information. It is having some license version. So whenever you have license version, that information cannot be transferred to other. That information will be the consumers and that our providers only. So no third party will going to be involved in that. And the most challenging part is the demand to manage, how we are going to manage the demand side management in proper manner. So for managing the demand side management, we should have good information. The information should not be lacking. So that to abstract the good information, we are using this IoT, and we for taking better decision, we have to store the historical data also. To store historical data, we are going for now big data or cloud computing. So store the big information of data so that we can take good decision among our good decision for demand side management.
Right, right. Okay. Okay, thank you very much, sir, and for sharing your knowledge. And thank you, all participants. Can we end up this session now?
Thank you, sir. Thank you, sir.
Okay, okay. Thank you, sir.